Hey guys, it's CMAC here. Welcome to SQL tutorial. We'll be building a database for an e-commerce application. This is going to be a hands-on experience from zero to hero, all the basic commands to advanced stuff, to store procedures, cursors, and everything. We're going to normalize the database. I'm going to teach you guys how to think about data models, how to map them from real world to basically database language. I've been working with databases for about 2 decades now. So we'll be using Microsoft SQL Server for our practice as a developer version, which is free. You can download it and start using it for development purpose. And then at the end of this video, I'm going to show you guys how to migrate your database to Amazon RDS service, which is a managed database service where you can basically deploy your databases and Amazon can take care of the rest. You guys can only focus on your database and data models as opposed to, updating the underlying system, being worried about security and management of your database. So we'll be using database migration service. If you're familiar with already SQL and you want to skip the first part, you're more than welcome to go ahead and just watch the DMS and basically RDS section. I'm very excited for this tutorial. Without further ado, let's get started.
All right, guys, we're going to start by installing Microsoft SQL Server 2019. Please use Google to find this location and go to Microsoft website and download the developer edition, since it's good for development and test database and not production. For production, you need to pay for the license if you're actually serving traffic. All right, once you do that, then go through the installation process. Once you have SQL Server, open your SQL Server and log in using Windows authentication. Now, I want to review a few concepts. A database is a set of data stored in a computer, right? You can actually use a text file. You can use Microsoft Excel. These are all the tools that you can, store data on your computer. However, if you want to store structured databases, structured data, and you want to find a relationship like a retail, e-commerce application that we're about to build, you need a place that you can actually store the data efficiently, and you want to be able to communicate, to ask questions. Hey, give me all the orders, between this date and that date, which, exceeded like $100. So if you want to talk to database, if you want to ask questions, from your data store, which is a basically structured data, you always want to use relational databases. So basically, a relational database is a type of database, right? It uses structure that allows us to identify and access data in relation to another pieces of data in the database, right? So for example, order with customer with payment. So these are all connected pieces of information that we're interested in. We want to put these together and basically translate them to something meaningful for business decisions, to get reporting, to help customers find issues, to track their orders. So remember, whenever you're basically dealing with some structured data. For example, invoice always has invoice date, invoice number, customer amount. So these are the standard, features, standard properties of an invoice, right? So if you know the data schema ahead of time, then that means you're going to have a relational database, or you're going to have a SQL database. So now RDBMS is basically a tool that we use in order to communicate with database, relational database. For example, Microsoft SQL Studio, MySQL Workbench. These are the tools that you use in order to communicate with your database. I want to just show you guys a quick thing here. A database, a relational database, as I mentioned, is just a model. It's a basically type of database that you're interested in that connected piece of information. And the language that we're going to use actually in order to communicate with our data is called structured query language, which is SQL. I'm going to create a new database. We're going to right click on the database and we're going to say this database called e-commerce, right? And we're going to say okay. This is how we create a new database. And as you can see, inside we do have database diagrams, which we'll be working with, and we're going to build a bunch of tables. Inside the tables, you have system tables and some internal tables where we'll be adding our tables to store data here. And we're going to, of course, create store procedures, basically reusable functions that we can call over and over. For example, give all the orders for the specific users, give me all the payments under this. So we're going to automate those. We're going to put them in the box, and then so we can call them over and over, exactly like programming languages, right? So what I want to do here, I want you guys to go ahead and right click on your database and go to security and make sure you are selecting SQL Server and Windows authentication mode, because we are about to build a login and make our database a little bit more secure. We want to have control over users, whoever is accessing our data. We don't want our developers accessing production data. There might be some sensitive data. We don't want, just full access for every single user. So in order to do that, what we're going to do, we're going to go ahead into security section. We're going to go to logins. We're going to right click on it and say create new login. I'm going to name this e-commerce, and I'm going to select the same password for it, e-commerce, e-commerce, e-commerce. We're going to uncheck the password policy to basically create a simple password. And we're going to go ahead to server roles. Server roles, if you guys pay attention, we have a bunch of different server roles, right? For example, system admin. If I give this role this access at the server level role, right? So this login basically can do whatever he or she wants to do. So you have different roles at the server level that you can control the access. I'll let you guys do a little bit of research on the roles, but big picture, understand that we can basically give users different accesses based on the role. And of course, we can map the user to the database. For example, if I select our e-commerce application, right, by default, every single user mapping database comes with public, right, membership. But we can say, hey, this guy can read and write, right? Or this guy is the owner, can do whatever. And the default schema, for now, we're going to say database owner. I mean, we're going to talk about all these. Don't worry about it. For now, just select OK. And so we have a username called e-commerce and password called e-commerce. So once you change the model from Windows to SQL Server mode, you need to restart your server. So right click on it and then click on restart. And then we're going to disconnect and reconnect to our database. This time, we're going to use e-commerce username and password. There you go. Now I have access over this login, whoever is using this login. So I know, people are limited to specific actions. So now we have a valid login. We are logged in using our SQL Server user, and we have a database called e-commerce. And if I expand the security and user, you guys see the e-commerce. All right, guys, now we are inside our database. We are logged in, and we're going to click on new query. So the first thing I want to do, I want to create a schema. Schema in the database is basically a logical separation between the tables. For example, I want to say create schema, right? I'm going to name the schema website. Why do I want to do that? Because I want to put all my tables related to website inside this category. This is logical. Remember, this is just a label that we are basically categorizing our tables. If I have a payment processing different API, I can put them on a separate schema. So that way I can identify my tables procedures easier. So let's click on F5 or execute. You can also check your command and to make sure it's okay. And you can click on execute. Now we have a schema called website. So what this means is basically I can create now a table. Table is a place that I can store my data. It's a row and column based structure, right? So all the columns is basically our information that we're interested in, right? And all the rows will be all the information that we'll be putting inside the table. So if I want to create a new table, I'm just going to create a new simple table, and we're going to just take a look at this commands and how this is going to work. So I'm going to say create a table inside the schema, inside this category that I'm interested in called website, and call the table users. So inside this user, I want to say what fields. So remember, inside the table, we have fields, we have columns, we have things that we're interested in, like invoice number, invoice date. These are all fields, right? For user, you name it. It's going to be user ID, right? And we're going to have first name, right? Easy. And what else do we have? We have age, right? So we can have all these information as a column. So we're interested into keeping first name and last name, or for example, age, right? So we have to tell SQL Server as programming language you guys are familiar that we need to identify the data type that we're trying to store here. So I'm going to say user ID is going to be integer, right? A number. And first name is going to be a bunch of characters or string. So we're going to name this varchar, right? And I'm going to give it some space. If I don't, SQL Server by default will assign the number, but I'm going to say probably first name 40 is enough, 30 is enough. So you have to do some guesswork here, right? And for age, I'm going to say the number is not going to be that big. So I'm just going to go ahead and use, for example, tiny int. It's a little number, right? So you guys see we have a bunch of basically headers, right? A field and followed by the basically the type of the data we're trying to store. If you go back to SQL Server data type, and if you guys scroll down, like any other programming language, we have numerics, we have strings, we have different type of, for example, data types here that I'll let you guys to take a look into all these. For example, if I click on tiny int, you guys see all the integers that are here. For example, big int, you see you can store a very big number, but it's going to take you 8 bytes. So you need to think about the type of the data that you are trying to store in your database, right? For example, integer, it's 4 bytes, but it's still a very big number. Small int, tiny int is between 0 and 255. And the reason I picked it for my age, because hey, maximum it's going to be 100, for example, 120. So you can take a look at all these data types, but I want you guys to pay attention to this important concept that you don't want to assign more than actually what's required or what you need for a specific field. I might be able to actually get by 20, right? Or maybe 30. So this is something you guys need to think about when you're designing your table. Hey, at the same time, I want to say this table user guide, it can be actually null because I definitely want to make sure every single user has an ID. Let's say your driver license ID, your passport number. This is the field, right, that you want to use to identify user. Think about it. This is the field that it's unique. So how do I actually say this field is unique? Well, it's very easy. It's called primary key in databases, right? So basically, when you want to create primary key, by the way, this is how you create comments in SQL. Basically, a note, anything you want to add that's not executable, you can just start by dash and then you can write. So primary key is basically, it's a field, right? Like here in this case is user ID that you want to use to identify unique values in your tables. For example, if you have an invoice table, invoice number will be your unique ID, right? So I'm going to create a constraint here, right? And I'm going to name this is going to be primary key. This is how the standard is going to work. You can use your own standard, but what I'm going to do, I'm going to say users. So you see PK followed by table name and then followed by basically field, right, that I want to pick. So that way it's very easy. Basically, I'm adding a label, I'm creating a constraint, and I'm going to say, hey, this is going to be primary key. And it says which field is primary key. I'm going to say user ID, right? So I am creating a table. Let's review what we're doing. I am creating a table that has 3 fields: user ID, which is using int, fname, varchar, and then age, which is tiny int. And I'm telling this table that I'm about to use this field called user ID as a unique value. I'm going to click on the white space and then hit F5 or execute. There you go. So now if I right click on the table, you guys are going to see we have a table that it's in website schema. So I have different schemas. So I don't have to look if I have a big database. So by creating this schemas, which we call it a website, we're basically adding a logical group to our database, to our table, so we can manage them properly. And you can also, give access to users only to specific schemas. For example, my, accounting tables that I'm creating and dealing with my accounting system doesn't need access to my website. So I can only give those users access to specific schema. That's why we have it. Now, if you click on this guy, you're going to see that we have a primary key. We named it called PK followed by table name, and followed by the field that we're trying to use as primary key. And here's my primary key, it's not null. And you have a first name and last name. So if I right click on a database, and then if I go to script table as, you see I have a select here, right? So get familiar with this process. So script table as, and then you have a bunch of commands. We're going to actually work with these commands, and then you can basically put it in clipboard. Or I can just simply click on select top 1000 rows. As you can see, at the bottom, I have user ID, I have first name, and I have age. And take a look at the default selection of data in SQL Server. So SQL Server is going to use a select. We're going to rewrite this command ourselves, and we're going to take a look at the data inside our table. This was just a simple way to access your data, access your table. All right. Now we understood that how to create a new table. We're going to go ahead and add some data to this table. So we created that matrix. Now we're going to use insert command, right? We're going to say insert into what schema? You guys know it, the schema called website, right? And then we're going to select the table, which is called users, right? So insert into this table. And we're going to say what values. The values is going to be, right, 100, CMAC, 39. Perfect. So we're going to say execute. And looks like a command went through. So insert into this table this values, right? So now I want to say, hey, I want to take a look at my data. I want to say, go ahead and select everything. So star means everything from website dot users, and I'm going to go ahead and only select this select, right? Remember, I'm going to select the select, and then I'm going to hit the execute. Now, as you can see, I have a table down here. This is my result. This is the grid that you guys see, right? And the message, it says one row affected because I returned one row. And it says user ID 100, CMAC, age 39. So this is how we basically select data from a table, right? We can insert more data. I'm going to say, hey, this is going to be John, and he's going to be, for example, 43, right? So we're going to only select this guy, and we're going to execute it, right? You see, now I'm getting an error. It says violation of primary key constraint because I told my database I'm going to use the first field, which was a user ID, as a unique ID to identify my user. But now database SQL telling me that, hey, you are inserting a duplicate key. You're not allowed to do that when you pick a field as a primary key because it's supposed to be unique, right? Now you guys understand why. So I'm going to go to 110 and I'm going to execute it again. Now it's going to see, you guys are going to see it's going through, and now I'm going to select the table. Now I have 2 users inside my table. All right. So what I'm going to do right now, I'm going to go ahead and delete this table, right? Because I want to introduce a new concept here. I can do it, by just right clicking on table and using delete, but I want to show you guys how to delete the table with the command. So we're going to use a drop command called drop table, and this is the table I want you to drop. There you go. So if you click on it, right click on the database, click on refresh, there's no table here anymore, right? Okay, what I want to do again, I want to go ahead and create the same table. All right. So this time I want to say USR ID, which is user ID. It's going to be int. And I want to say I want to use identity, right? And the identity command is basically is going to give me a base to start generating, primary key number without me identifying those IDs. For example, I want to say start from number 1 and then add 1 by 1, and it's going to be not null. You guys are going to see shortly what will happen here. So name, you guys remember, I'm just going to practice once more. This is going to be 30. It can be can accept null, right? And I'm going to say age. This is going to be tiny int, right? And this is going to be not null. Not going to allow users to add this. And you guys know when we want to add a primary key, we are going to go constraint. You guys know that we're going to add constraint. It's going to be, we're going to tell this is a primary key followed by table name underscore. We're going to say USRID. All right, this is how we identify this. And it's going to be primary key. All right, and the primary key is going to be this guy, right? So this time I'm creating a table that already has a mechanism, has a system to generate those unique numbers instead of me defining those numbers, right? Let's execute this command. Now I'm going to go ahead and insert some values here. So this time I want to right click on my table and I'm going to say script add table as. I'm going to go to insert and I'm going to copy this to my clipboard, right? And I'm going to go ahead and paste it here. Perfect. So if you guys take a look, SQL by default use e-commerce, because if I change my database for different, let's say I have 100 databases here. If I change my database and if I execute this command, it's going to look for a website user and say, I don't know about website users because you are using a master database. So if you use command, right, in order to change, pay attention to the top left next to the execute. It's going to automatically change the database to e-commerce. That's why SQL by default has this. And Go is basically, it's a end of a block and a start of a new block of commands, right? So if I remove those extra lines, you're going to end up with user insert into website users. It does have two fields, right? This is SQL. And if you see, it says, give me only values for first name and last and age. Why? Because I told a database, hey, you need to handle the key generation, the random or the sequence number that I want you to create. So I'm not going to deal with that. So when I want to insert the value, I'm not allowed to provide any primary key values because I told SQL to use identity, to use a mechanism in order to start generating numbers for my database, for my rows. And this way I'm going to say, hey, start with number 1 and add 1 by 1. So first user will be 1, second user will be 2, 3, 4, 5, and, etc. So let's say I want to start generating IDs by, let's say, start number 1000. So the first user will be number 1000. The second one will be 1001. So this is how it's going to work. I'm going to add a user. Now I'm going to say CMAC, right? And the next user, and it's going to be 39. I'm just going to select only the start and I'm going to say execute. This is one row affected. The second one, I'm going to say add John, right? And there you go. And the third one, I'm going to say just add Adam. So you see, I'm not dealing with primary key number creation, right? So if I right click and say select top 1000, there you go. So as you can see, users are now from, all right, now I'm going to create this. I need to delete the table and recreate the table since I changed it 1000. I'm going to refresh this. There you go. I have the table. Now I'm going to go ahead and add a new user. So insert to this table. Only I'm going to provide a name and age. For example, the second one is going to be John 40. The next one is going to be Adam, and it's going to be 29, for example, right? So I'm only providing username and age, right? So if I go ahead and right click on my table and select some data, you see now SQL start generating IDs from 1000, 1001, 1002, and I don't have to deal with those IDs. So primary key is basically as a field that you use in order to target your specific field. For example, if I log into my website, to the e-commerce website, and I say, hey, my name is CMAC, and as soon as I return the ID, for example, 1000, so every single query that I'm about to execute to get the orders, to get the payment history and everything is going to use this number to identify all the orders that's related to me, right? But again, remember when we use identity, there's a starting point and we start adding the numbers, in a sequence that we want, and we're going to let the database deal with this, key generation. So far you guys learned how to create a new table in your database and how to insert some data and of course how to select some data. So select star, right? select store, which is everything from e-commerce, website, user. So it's basically select everything from the database, from the schema, and from the table. So we're drilling down and finding our table, right? So let's say I only want to select the first name. So I can only say, hey, select only first name from this table. There you go. I can say select first name and age, right? So by using the field name followed by comma, we can separate them and tell SQL to return only the fields that we need. There's a performance tip here that when you're building real life applications, so using select star is a very expensive operation. Imagine you have 100 fields and you have millions of records and you're trying to return everything. So there is going to be some performance issues there. So you guys want to make sure when you are issuing a command, let's say we are checking, for example, if someone is trying to buy alcohol and we want to make sure that person is not allowed to buy it, or the person is trying to buy something that we want to check the age. So you can only return what age of this person, as opposed to returning all the 100 fields and everything from the table. So you need to think about the field that's required for the specific use case, and then you just issue the select command that you're interested in. All right. So we're going to close this guy. I'm going to say no, and we're going to empty our page because I'm about to give you guys a new table. All right, we're going to drop this guy. Let's say now we're going to go ahead and create a new table, right? Which is a users table. It's the same table, but we're going to actually expand this concept and make it a little bit better. So first of all, I'm going to start by number 1, and I'm going to go to 1, and I have a first name, which is 30, and I have a last name. There you go. It's going to be varchar, and this is going to be, let's say, 30 again, and no. So if I go back to my data types, right? Let's take a look at 2 things. For example, if you see, it says for character settings, you have a few options, right? And char, text, and varchar. You can take a look into these, specific details. But take a look. I have a unique character settings as well. And if you click on varchar, you will see that char is basically using UTF 16, right? There you go. Which is a bigger just data set, as opposed to char or varchar is basically using UTF-8. So if you're basically, for example, building multi-language website, it's better to go probably with varchar, right? Because you want to be able to have all those UTF characters in your data. So based on the data type that you guys need, you can just take a look and make sure you are selecting the right format or data type for your database, right? So let's go back for last name. Since we're working with English, I'm just going to use varchar at 30, right? And then I have a username field now. So I'm introducing a new concept here. And the username is going to be, again, varchar. This is going to be 30 or 40. And it's going to be not null. So you definitely need to have a username, password, right? I'm not going to allow to leave the user first name and last name empty as well. And I'm going to have a password. So I want to, on purpose, I want to store this data in a basically clear text. This is a bad practice, and I'm going to show you how to fix it. So I'm going to store the password in just plain text, which is again very bad practice. And I'm going to have a field called status. I'm going to use this as a bit. So bit it can be 0 or 1. I'm going to say this the user is active or not active, right? So it's basically will be 0 and 1. And then instead of age, this time I have a DOB, date of birth, and I'm going to store this as a date function. I'm going to say, hey, the user profile has a photo, and I'm going to say this is varchar again, and it's going to be 100 because the file name might be a little bit longer. So DOB, again, it can be not null, right? And we don't want user to leave this empty. And this one, of course, is going to be not null. Date of birth, I can just leave it empty, or you can just force the user to provide this value. There you go. So I'm ready to basically go ahead and execute this command. Now I have a new table that has a little bit more information in it, right? Can store a little bit more information. So what I'm going to do, I'm going to actually right click on the table, or I can just start typing the insert command, but I'm going to go to insert and I'm going to go to clipboard and I'm going to open a new query, and there you go. So as you can see, use again e-commerce, go. We're going to start building our insert command. So for insert command, you don't actually have to provide all these. SQL does that by default, but you can actually remove those and just provide the fields that you're interested in, right? So what we're going to do, we're going to say our first user is going to be John Smith, right? And we're going to say this person username is going to be JS, John Smith, right? And his password is going to be JS 1980, and this user is active, and this user is 1980-0101. It's his birthday, and I'm going to locate the photo that he uploaded to my web server, and here's the path to his photo. So I don't have to store the photo. I can do that, but I'm just going to point to the address of the image on my server. So when you load the photo, you can just basically provide this as a source of a photo in your website, for example, right? So let's go ahead and actually insert this to our database. There you go. Now we're going to go back and right click and say select. Perfect. So I do have one user that inside my database that has username and password. Obviously, you see what the problem is. We're storing the password using basically just varchar field, which is a clear text. If someone gains access to my database, they can simply just see the password, and that's very bad. So we want to fix this problem, right? We want to fix this problem. In order to fix this problem, we're going to make some changes to our database, right? So what we're going to do this time, we're going to say, hey, let's close this guy. First of all, we want to empty our table, right? And the way we want to empty that, we're going to say truncate table. This. So truncate will basically delete everything from your table. If I right click and select now, there's nothing in my database. So you can empty a table efficiently using truncate table. However, you can use a delete from command as well. So I can say delete everything from this website and user database. Remember, it doesn't have star key anymore, and it says 0 row affected. But delete is basically going to go row by row, which is not that efficient. You always want to use, I'll show you guys how to filter data and delete specific records, because that's basically delete is for. But if you want to empty the entire table, what you can do, you can just use the truncate command. All right, so now we truncated the table, right? But the table is still there. Let's drop the table because we're about to create a new table. So drop table user. Perfect. Table has been dropped. If we right click on tables and we refresh, there's no table here. Perfect. So what we're going to do, we're going to keep the user ID, first name, last name, username, but instead of just using password as a clear text, what we're going to do, we're going to say we are interested in a password hash, right? And we're going to keep this as binary 64. We want to hash this password, right? And store the hash inside the database. Is basically hashing is a one-way function, right? Let's say I do have a password 123456, and then I'm going to use a hash function, which is a one-way function, and it's going to create a password like this for me, right? So take a look, 12345 something 6. It's converted to a bunch of characters. Hashing is a one-way So you can basically go back from hash to 1, 2, 3, 4, 5, 6. And when we want to compare the password, we're interested into comparing the hashes because we can go back and find the actual password. So that's why when you reset your password, majority of the website, they can actually tell you what the original password is because there's a function, right, that's converting your raw password to a secret password, right? And there's no way to go back. There is actually, but it's so expensive and you have to spend a lot of time in order to, reverse this. But a lot of advanced, hashing functions, they're, close to impossible to break. So what you want to do, you always want to use, hashing function or a mechanism to convert your raw password to an encrypted one, right? So in database, there's a lot of actually techniques using that. If you're using, for example, Java, for example, you can use bcrypt as one of the best encryption algorithms out there. There's a lot of encryption algorithms out there. It's outside of the scope of this tutorial, but keep in mind that we are not interested in keeping our password in a plain shape in our database. So what's going to happen here, if I go back and we created a table, let's see, let's make sure we created a table. Yes, it says there's already a database. So if I refresh, it should be there. Perfect. I'm going to select, there it is. So we have the table here. Now I'm going to go ahead and actually insert a row here. All right. So we're going to go ahead and create a new query, insert into database. So the first name this time is going to be, again, John Smith, right? And username is going to be, again, JS, right? So for password, now I want you guys to pay attention. I want to say, hey, use hash bytes, use algorithm called SHA-2_512, which is the basically most recent one and secure one. And use this password. This is going to be my password. Hash this password, JS1980. You guys remember the password. And then insert to my database. So basically, I'm telling SQL, use this hashing function as SHA-2_512 and encrypt my JS1980 password and insert it to database. This is going to be an active user and it's going to be 1980-0101. And the photo, we're just gonna say image/John-Smith.jpg. Perfect. So let's see if this works. It says created. Now we're going to go and select everything. So now you guys see I inserted a password called JS1980, but you can see SQL by using that hash byte function created a hash for my password. So if the user logs into my database, I'm interested into checking the hashes to see if the value, right, that you creates the same hash as I have in my database. So I will compare the hashes as opposed to, raw password, right? So there is a little bit of issue here. So now the hacker can actually understand, okay, I'm using some sort of hashing function. So if I create a mechanism that checks multiple passwords every second, hundreds of passwords every second, and checks the hashes. So if two users have the same password, for example, 1234, so as soon as I break one, I will have access to a lot of users, right? So, and that's going to be another problem. So what we're going to do this time, we're going to again drop this table and we're going to modify it and make it a little bit better and secure, right? So this is my select, this is my creation command, right? So in password hash, I can add a extra field, and usually they call it salt, right? And this is going to be a random character or random number, right? Which is going to be 6, basically, digits, 6 characters, right? The length will be 6, and this will be basically a random number, right? It's something that I will generate for every single user, a random number while they're signing up for my website. So this will guarantee if two users, they have the same password, which will end up having the same hash function, but they're going to have a different salt. So if you break as an hacker one of my passwords and you want to check majority, other users to see if someone else uses the same password, this technique will prevent that, attack. So because I'm creating a random number during a user creation process. So if now we go ahead and actually recreate this website, I want to show you exactly how this works. All right. So now if you refresh, you guys definitely know what we're going to see here. We have a field now that is extra and it's called salt, right? So we're going to add a random number while we're adding a new user to our database in order to basically prevent those hackers accessing basically hacking all of our users' passwords, right? So in here, what I'm going to do, I'm going to go ahead and basically I need to create a random number, right, before inserting the user into the database. So what I need to do, I need a variable that creates a 6-digit random number. So we have to define a variable. How do we define a variable in SQL? We say declare, right? We're going to declare and we're going to name this salt. I'm going to say this is going to be integer. It's going to be integer, but eventually I'm going to convert it to a string and connect it to the password and make it more complex. That's the beauty of it. So set, we're going to say set this value. How do we assign? I'm going to say set this value, give this variable. So the formula is going to be, I want to say from the left side of my random function. So there's going to be a random function and I'm going to basically multiply this by 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to tell you why. I'm going to add 999 as int. And this is going to be 6 digits from the left side. Okay, let me walk you through this process. We might get 0, right? If we get 0, our number that's need to be 6-digit, it's going to guarantee if we create a 0 here, 0 times by this number will be 0 plus 99. That will guarantee that it will have a 6-digit salt if the random function, it's inclusive. Basically, it's going to end up having value 0. So that way I'll add this 90 if there is a 0. So guarantee I always will have a 6-digit. So this random will basically inclusive 0 but exclusive 1. So there's going to be a number from 0 to before 1. And then I'm going to multiply this by this number and just get the 6-digit from the left side. So I'm going to just select this variable. So let's create this. Looks like I'm missing something here. Decimal values. Let's say select rand. If I select this guy, let me show you guys. This number will generate something like this, right? And then I want to multiply this number by 1 billion, which I'll end up having something like this. So if I refresh, I will have a random key every single time that I'm generating or inserting a value, right? And I have the random number. And then if we now select this entire thing, you see that now I have a 6-digit number that's unique every single time that I'm hitting this procedure. So there you go. So I created a variable. I said this is going to be int. I eliminated all the decimal values by casting this value to an integer. So remember, you can convert a decimal to, for example, integer, or to string, to any conversion data type. You can do it using cast. And then I say from the left side of the entire result of this long number, please only select the 6 left, because I'm only interested in 6. If I'm interested in 10-digit salt, I can go ahead and select the 10-digit salt. There you go. It's going to give me every single time, for example, a different number. But in this scenario, we're going to go with 6. So now I have a random number that's 6-digit, and it's unique for every single user because it's completely random. Now I can actually go ahead and use this number down and then add only my at salt. There you go. So I created a variable that creates this random number, and I'm using that in every single time that I'm inserting a new user to my database. Now, if I go ahead and execute this number, perfect. Now I do have a error here, and the reason is I declared this as an integer, right? So, and I'm telling my database, hey, I'm going to give you a character. You guys see on the left side, it says data type is character, but I'm inserting a integer basically to my database, which is not okay. So what I'm going to do, actually, I'm going to cast this as converted to character, actually, not varchar, just char, and this is going to be 6, right? And insert it into a table. But I wanted to create this random number in order to make my password unpredictable, right? If two users using the same one, but they're going to end up having different salt keys, basically secret, unique secret. So I want to kind of include this, add this, integrate this variable into my password creation process. So I'm going to say you have the password JS1980, and I'm going to say plus cast this salt, right? Salt. And I'm going to say as character of 6, right? And add this random number to my password and then hash it using SHA-512 algorithm, right? SHA-2. And then I'm going to go ahead and select everything and insert, right? Error, and the reason is I said I have the password hash, but I need to add a salt here to my insert. Let's execute again. There you go. I have one row in my database. Now I'm going to go ahead and refresh this. Perfect. So now you guys see, if I actually select salt and execute the command, now I have a random key of salt that's basically integrated into my password. So if I add a second user, let's say Amy Smith, and she's going to have a different password, right? And if I insert the second user and go back and select the records, now you see she has a different salt number that's basically creating a different password. But what if two users, they have the same password? Let's say JS1980, and this will be basically, again, John Adams, right? But he has the same password as John Smith, but they're going to have a different salt, which is going to have it basically create a different password for these users. There you go. So the user number 1, John Smith, right, has password JS1980, and this guy has JS1980, but they have different password hash, right? Hashes. And because the reason is that random number helped us create a unique password every single time. So if I have a database with 1,000 users, they pick the password test 1, 2, 3, they're going to have different passwords. So if a hacker kind of gets into my database and finds one password, he or she will not be able to crack the other user's password and get their information. So salt is always, you want to make sure you add to your database in order to make your login process harder to break. All right, guys, now I want to add basically a few users. I have John Smith with this password JS1980, and I have Kyle Adams, Adam Smith, and Susan Rice. So I have like a bunch of users here that I'm about to add to my database. And for this particular example, I'm just going to use the same salt key, but you guys now know for every single user, you need to run this command. Basically, this command needs to be something like this, right? So every single time you want to create a random number and then basically insert that. So let's run this command. And we do have an error because I don't have an equal, right? Salt equal. I want to set this value, so I need to put equal sign. There you go. I now have 4 commands here. I'm going to close this guy and go to the Object Explorer and refresh and select all this users. There you go. So I have 4 users with different user ID, which is a primary key, right? And they have password hashes and different salt keys. Perfect. So now you guys see here, it says select top 1000 user ID. So if I want to change this to select top 1, so this is only going to return only 1, right? And I can just say, hey, for example, I only need to select username and password. There you go. I'm only interested in top 2 users, right? So this is basically how you filter the columns, and you can say how many rows basically you are interested in. That way you can control the columns and the rows of your table. So what I want to do right now, since I created this e-commerce users table, what I want to do, I want to go ahead and actually start creating the logging process. Let's see if we want to simulate that. Let's see if we can do that. So I'm going to declare a test user, right? I'm going to say this is varchar, and it's going to be 20, and the username is going to be AA, right? Which is this guy, for example, Kyle Adams, right? This is his username, and then declare @test pass, and this is going to be again varchar 20, and his password is going to be we inserted AA 1980, right? And this is his username and password. This is a valid username password, right? And declare the last one is going to be @salt exist. We want to see if salt exists. And what do I want to do here? I'm going to say this is going to be character, and it's going to be 6 characters, right? And for now, it's going to be salt is going to be 0, because we want to see if the salt value exists, right? And then we can check the password. So what I want to do, I want to go ahead and do select @salt exist, right? This is going to be, select typo @salt exist equal to salt. I'm going to tell you what I'm doing. Salt from website .users, right? Where username, I hope it's username. Yes, it is username, equal @test user. All right. So what's happening here, I want to say store a result of this selection, right? From the table where my username is equal to this username that I'm providing. So if I want to rewrite this in a simpler way, let me do that before. So I want to say select salt if the user is equal to test user is equal to AA, right? But since I put it in variable, I can just use the variable name. It says yes, the salt exists, and if I do everything, you're going to see this is going to only return my Kyle Adams, which has a username of AA, right? So I can filter data with by using keyword where and the field that I'm trying to filter. If I want to use 2 filters, I can use and. For example, first name equal to Kyle, right? So let's select this guy. It's going to return something perfect. And if I change this to, for example, John, this is not going to work because I'm trying to satisfy 2 conditions here, right? So I'm saying username must be this and first name must be John, which doesn't exist, right? But if I use or, it takes only one of this condition to return this, result set. So it's either AA as a username, which is this guy, or the first name is John. So this will return 2 values. So if you want to basically add more filters and restrict your results that you use, and or if you're looking for possibilities based on few different values, you can use or. So in this example, if I basically say hey test user, which I have it as an AA, this is going to again return 1 user, right? Let's see. I need to select everything because I'm declaring the variable here. And the salt for this user AA is going to be 959456 something. So I'm just only interested in the salt field because I want to make sure this user exists, and I want to use that salt to basically check the password. So if I click on it again, I need to select everything. There you go. So it's returning the salt. So when user in a website enters his or her password, a username, I can check to see if the salt is exist for such a username, right? This is how you check it. Now, I need to store this salt value because I'm about to calculate the hash. So the way I do it, I created a salt exists variable, which is 0. And if I say, hey, select salt, right, from this based on this condition and store it in salt exists. So if I go ahead and basically select @salt exist variable, I should be able to get some result. Let's see. Salt exists. There we go. I misspelled that. Perfect. So it says salt exists and it's returning the salt. So now I know if salt exists, I need to check the password, right? I need to check the password. So I need a conditional statement, which is if. So I'm going to say if this guy is not equal to 0, right? Because the default value is 0, but if there is something, it's going to be some salt 6-digit, 6-character, variable. So if there is something in there, I want to start doing something. So there's a block here. I know this is going to be a beginning and end of my block. So it says, okay, what do you want me to do? I say, hey, go ahead and select, and tell me this is a valid user, right? And dash user ID is going to be equal to, I need to put this. So SQL is going to create this basically text for me, plus and cast user ID, USR ID. Remember, in our user database, we do have USR ID field, right? So cast user ID as varchar, right? From this table, correct? I don't need to retype it, from this table. Now I need to add condition where you guys know username is equal test user, but I need to combine it. I need to make sure the password and username matches, and password. I don't need to put it in the bracket, but it's best practice as a SQL default command. You can just put it or ignore it. Password hash is going to be equal to hash the password, so hash byte. Now I'm just going to check the hashes because I cannot reverse the hash using the SHA-2 underscore 512, perfect, and @ test password plus the salt that exists. So this is how we calculated in the beginning and created the password, right? So we created the salt key. Now we are retrieving the salt key to see if the salt exists. Now, if the salt exists, we're going to add whatever user entered as a password, which is AA1983, combine them together since they're character both, and basically calculate the hash using SHA-2 algorithm and get the hash byte, and then compare it to the field that I have already in my database. But this happened after actually checking the username. We made sure the user exists, and now we're gonna go ahead and check this guy. So let's run this out. Perfect, it says valid user ID 5. But if I change the password to 1981, this should not work, of course. We're not getting anything. You can add else if you want, but not returning anything, meaning we didn't get to this part. So let's say we provide a good username, but this time we're going to create a bad username, right? So the username doesn't exist, right? Since the username doesn't exist, we're not going to get anything back from the username filter, right? So basically this will be 0, and we will not go through this, select statement. But if the username exists, so that means there is a salt that we created during the runtime, during the user creation, and now we are filtering our table based on the username because we know the user exists, and also we want to satisfy this password hash, which is a combination of whatever user provided because plus the salt that we found from our table. We calculate the hash, we comparing the hashes. We are not able to recover the password. Remember, we are comparing the hashes to make sure the user is valid. So this is a login procedure. We're going to later make this into a basically procedure and reuse it over and over and over. All right, so now I'm going to create actually a procedure that basically, gives us a reusable method in order to call every single time that user wants to log into our e-commerce website, right? So, and the way we're going to do that, we are going to say, hey, create procedure, right? I'm going to name check user name password. There you go. I'm going to say this is going to be receiving username and password from a user, and as we're going to start building our procedure. So we're going to remove all these. We don't need the declare, as we are declaring this as a parameter. So we're going to say we're going to receive two variables, right? Whatever user passes, and these values are going to be provided by user. They're going to send us these two values, and then we're going to work with this. So let's create on click on execute. There we go. Now we should have in store procedure here that we can use over and over, right? Every single time that the user hits our backend API, we can just call this procedure over and over. Let's right click on it and execute this. See if this works. So user is going to be AA, and the password is going to be AA1980. There you go. It says user value, right? So if I rerun this with a random, so we can return whatever we want. So user test password 1234 doesn't exist, so we shouldn't be getting anything. So it's returning 0. So you can return any value that you want and let your, for example, backend send the username password invalid to the front end application. So this function now can be used over and over by just simply creating a new procedure. So now we're going to actually select the users. All right. And what we're going to do, we're going to actually apply a few apply a few filter here. All right. So let's start with status, right? So where status equal to 0. Let's say 0 means user is not active, for example. So we can find all the users that are not active. For the next one, we can copy the same thing, and now we can actually start writing on first name. For example, when first name equal Susan. There you go. So now you can actually select this line and only select this user. So now we're going to apply a filter on last name. But we're going to go with like. We're going to say anything that ends with S, right? If last name ends with letter S, we want to see that result. There you go. We have one. So if I go ahead and add this, add the percentage at the end, basically I'm saying anything that contains letter S. There you go. So last name, see the position, it doesn't matter. I'm saying before S whatever and after this whatever, I really don't care. But I want to say, let's find all the last name that starts with letter S. So we have two last names that start with letter S. So wherever you position this as percentage is basically going to filter the result. And then of course here we can say and status equal 1. We know it's going to be basically John Smith. Let's see. All right, I'm going to select it. There you go. We have it. So let's work a little bit with date function now. In date function, if I select everything, and in this one I can say, for example, where DOB is greater than 1981. I want all the users 981 0203. That's 03, and I'm going to find out all the people, and basically looking for date of birth greater than, the state. And as you can see, we have two members. So if I say, I want this by 1980, you're going to see probably more results. And then I can, of course, say where DOB, you guys know, now I can filter actually the date range, basically, and add this. So let's say DOB is less than, for example, 1985 -01 -0. There you go. So this is going to actually filter all the records between the two dates. For date function, we can actually do one thing. It's very common for date function. We can say where DOB, right, between this and that. So we can actually remove the field and only use it once, and then use the keyword called between first value and the other value. So we can do the same thing for numbers, for integers, for all these different values. So one thing I want to show you guys here, I want to say where name in. So when I want to select multiple value, you might want to say, hey, I want, for example, our first name is actually called John, and then also called Adam. So you can also, select multiple values using, keyword in, and then provide all the values in the parentheses open and close. All right. So now that we have the, user table, and we have a bunch of fields in it. Let's say I have a user, and, it's going to change the, last name. For example, let's say our first name Susan, we're going to change the last name to, for example, Jordan. How do we do that? All right. So in order to do that, we're going to use a command called update, as it indicates it's going to update the value, and we're going to say, and then we're going to say website, right? Or schema users, right? Update this table. We're going to use set value last name equal to something, which is going to call it Jordan, and we're going to filter the result that we're trying to actually update. Otherwise, it will update all the table. Remember, if I run this command that I selected, it's going to basically update all the rows, all the last name to Jordan. But I want to apply only this update command to specific, for example, first name, and I'm going to provide the name right here. So when you guys want to use update and delete command, I definitely recommend that you guys basically start a transaction. And the reason for that is, if you make a mistake, right? If you make a mistake by applying a wrong, let's say, update or wrong delete, you can basically roll back. Let's say I make a mistake here, and I want to update I will only, for example, usernames, first name Susan, but I want to by accident, I just go ahead and update everything. See, it says 4 row basically updated. So, and if I run the command, I basically messed up my database. Now I need to go back, find a backup and restore it. It's going to be a problem. But since I put this guy in a transaction, I still have a chance of roll back. So I'm going to go ahead and use rollback command. And I'll say, wow, I made a mistake. Sorry about that. But now if I select, you will see everything is back. So definitely, use rollback and commit, or basically a transaction block, if you want to update or delete something in your table, just in case if you make a mistake, you have a chance to go back. All right, so I'm going to run this guy, and it says the command is wrong. The transaction never actually happened. Now it says there's one record. I'm going to say, hey, I'm happy. I did everything right, and now I'm going to go ahead, just commit the transaction. Now, if I select the data, you're going to see only this row has been affected. So remember, always when you want to use update and delete, my personal experience, always use basically transaction. So, all right, I'm going to just go ahead and, for example, delete this row, right? Again, I'm going to first run it to make sure there's only one row. All right, that's the row I wanted really to delete it. Now I say, please commit this transaction. I deleted the row. Now we have 3 rows in the table. Well, now let's go ahead and take a look at a few date function in SQL Server. For example, if I want to get the current date, I can just go ahead and say, hey, select date. There you go. If I execute this guy, you see here's the date, but the table, the column basically doesn't have any name. I can just say, hey, this is called current date. And if I run this guy, you see now it's labeling this as a current date. So I can go ahead and select date part, right? Date part of basically it's just a part of the date. I just say, hey, I want the day. You can get day of year or weekday from what? From get date, because get date is always going to return the current date. And there it is. If I run this guy, this is just going to basically return the day. And then if I select, for example, a date difference, right? Date diff. Date difference is basically the difference between two dates, and I'm going to say get date -7 is this is a week before, and find the difference between get date and get date -7. This is basically going to find the difference between, this is going to get diff between the 2 days. There you go. There are 7 days because this is 1 week starting from 1 week to today, and I'm saying, hey, find it based on day. So there are more things here. If I want to basically format my date here, let's say I say, hey, convert my basically date to varchar, right? And here's going to be get date. Let's use the same thing. And I want to just convert it to this normal format. Let's just say June 7, and here's the date and time, right? So if I copy the same command multiple times, I can convert this to different, for example, formats. 101, let's say 110. If I do, for example, 102. So if I start running all these guys, you will see that the format, date format will change. So this is just the shows the year as like just 2 digits. All right, guys, now we're going to start actually building our product table where we're going to keep, for example, a laptop and 2 iPads and maybe a camera for our e-commerce website. So let's say we have a create table command you guys are familiar with. It's going to be website, and we're going to just add the table name, which is called products, right? And inside the product table, we're going to add a bunch of fields, right? So the first thing we're going to add, you guys know, it's going to be product ID. It's going to be integer and identity, right? Because this is going to increment all the numbers. Identity, I misspelled it, and it's going to be 100 and start with 1. It's going to be not null. Identity, perfect. And this is going to be product char, let's say 50. It's going to be not null, and we're going to add product description. And this is again going to be varchar, for example, 200 description, and again not null, right? We're going to have a price, right? And this is going to be decimal. It's going to be 19 digits, and I'm going to have precision of 4. All right, let's say this is enough for now. We're going to create a product primary key on product ID. You guys now know if you want to identify a uniqueness of something in a table, you use primary key, and you tell the table, hey, you'll be using this product ID, to create unique values in your table. So there's going to be a constraint. There you go. We talked about this. Is going to be primary key underscore table name underscore the field, which is the product ID that you're trying to basically use as a primary key. And this is going to be primary key product ID. Awesome. For product, right? We want to make sure our product, that the description of the product is unique. For example, if I add a Canon, DSLR, this model, I don't want to, give users the opportunity to basically insert duplicate values. How do I prevent that? Well, the one approach will be, hey, you can check the table. You can query table and have a select function and see and add the var clause to see if you can find that value, and if that's successful, which is 0, it doesn't exist, then you insert. But that's a lot of operation. So SQL internally do have this constraint that you can create, and we're going to say we're going to name this unique, right? Unique, for example, uProduct. I'm going to name this uProduct, and I'm going to use something called unique, which I'm telling this table, hey, I want to make sure the product field on this table is unique. I'm going to show you guys, I'm going to try to add a, duplicate value to this table, and you guys see that this is not possible. For example, if you're building a website and you are asking users to select a username and you don't want, similar username, you can actually use this unique function in order to make sure your username are exactly unique and they're not duplicated. All right, again, we're going to have insert into product table. And here's my product table. As I said, you can identify the fields that you're trying to insert. But in this case, as you can see, since our primary key is going to be handled by our database, our products is going to start with a number 100. This is the ID and incremental 1. And then you just need to provide 3 values. And as you can see here, I'm just identifying what values I'm providing here. And let's say the first one is kind of, I'm just making up this, product. These are not real prices. It's just for the purpose of this practice. These are not real product and practice prices. So Canon DT4, I don't even know that model exists. That's going to be $200, right? And in the next insert, as you can see, I eliminated all these because SQL is smart enough to understand, you're just trying to add the values that, after basically I have primary key, because primary key is already handled. So the Dell laptop, Core i7, 8 gig, that's the $1,000 laptop, and you have 2 type of iPads. One of them is 32, one of them 64. I rounded up all these numbers, made up all these numbers so it's easier to query the numbers. All right, let's insert all these 4 records. I never created the table. I'm sorry. Let's create the table. Now let's insert the values. There you go. So I have 4 values. Now I have the second table in my database. There you go. Let's refresh this. And here's my products table. Let's select the products. Beautiful. Now I can just change this to star, right? And we'll remove the first line. So I'm selecting everything from e-commerce, website, and our products. Here are our products. Now we're going to actually write maybe a simple few functions. So as you guys know, just to remind you guys how our clause works, we can just say, hey, I want all the products under $330. All right, guys, now I'm going to actually return only the minimum of the price in my table. So I'm going to say, hey, from this table, just select minimum of price. There you go. And this is going to be a minimum value. There it is. I can select the maximum value. There you go. This is going to be maximum. I can select the average value. There you go. This is going to be average. I can say, hey, find the sum of all these values. So remember, always you have these, sum, average, and all the common functionalities that they're built in SQL, and you can use them wherever you want them. All right, guys, now let's say I want to add the product. Imagine we had a table, right? In our table, we had, for example, the product, and then we had for example, country of origin, who made this product, right? And then we want to count how many, product, for example, we have from Germany, from England, from USA. So that way we can use aggregate function in conjunction with group by command. So you always want to use group by when you're trying to group things in one category. For example, if I want to group everything in product, let's do this. So I want to group everything or product, and I'm going to count the price. So I have one price for product called Canon. I have one price for this. I have one price for that, one price for the other one. So you always want to use this aggregate function in conjunction with basically group by. And then you can also add, having basically count the thing that you're working with, count the price. It's for example, more than 1, which in this case is going to be nothing. So this basically says, hey, give me all the products that you have 2 prices for. And this says, hey, I have no product with more than 1 price in the table. Imagine we had a country in this product, right? And you had 10 products from Germany, 5 products from England, and 6 products from the US, right? 2 products from Canada, and you wanted to count the number of products from different countries, right? And then you could basically use the same concept and basically filter, and you wanted to have, for example, the countries that provide more than 5 products in your website. So you could use the same group by command in order to find that. So one last thing I want to show you before I move on to the next subject. If I select the price, let's copy this command. Actually, I'm just going to use this. Let's say I want to have a maximum of the price, right? And the maximum of price, I believe, is going to be 1,000 for the laptop. And the second one is going to be minimum, right? And the minimum is going to be probably the iPad, right? So if I want to show minimum and maximum in one table, I can use something called union. Basically, it adds the two results set together and it returns in one unique result set to the user, right? But remember that the number of the columns and the fields that you're using need to be consistent in the both select commands, so you can basically use union in order to merge the result set. We're going to use create table. And again, in the same schema, website.address, and you guys know the drill now. And now we're going to just go ahead and use the address. There's going to be two fields in the address. The first one is going to be address ID, and this is going to be integer identity, right? And it's going to start from 1 and add 1 at a time. So, and then physical address, varchar 60. It's just some random number on top of my head. And then we're going to add a constraint, and the constraint is going to be, again, it's going to be primary key underscore followed by a table name and underscore the field name that you're trying to use for primary key. So this is going to be now primary key, and the primary key is going to be address ID. All right, so that looks good. We're going to actually execute the command, and we're going to add a multiple addresses. So there you go. So I have insert into the table value and some just random addresses. These are not valid addresses. I just make them up. So you guys can find all these commands, by the way, in find the link in the description section. You can find it in my GitHub repo and download them instead of just typing them. So let's run this command, and there it is. We have a bunch of addresses. Now if I go ahead and right click on my tables, it says addresses. So let's right click on this guy. Perfect. So I have address 1 through 6. And these are just physical addresses, right? They're not connected to any specific user, but in the next step, that's what we're trying to do. We're going to connect those tables to basically our users. All right. So I'm trying to introduce a new concept here to you guys. Just bear with me. This is going to be very easy once you get it, right? So I'm going to create a table called create table. All right. Create table, and this is going to be again same schema website dot, and it's going to be customer shipping address. And a customer shipping address, we're going to have basically 3 fields here, right? The first one, I'm going to name this foreign key user ID integer. Right? Again, bear with me. I'm going to explain this. This is going to be very easy. There's going to be another foreign key. It's called address ID. And this is going to be integer again. And I'm going to say, is this address active? Right? And I'm going to use bit, for example, 0 or 1, and can't be null. Perfect. So I am basically telling my database that there is a mapping between users and between physical addresses. So basically you have 3 tables: user table, address table, and in the middle you do have customer shipping address. I'm going to create a diagram shortly and show you guys how this works exactly, but bear with me. We are connecting, we're referencing back, we're saying, hey, we're trying to use this mapping table to connect our users to our physical addresses. So in physical addresses, you guys saw we have a bunch of physical addresses, but we are creating customer shipping address in order to connect our users to those physical addresses. And we're going to basically apply some rule to make sure you can't ship the package to the wrong address. So what happens here, right, in active, let's add the constraint. So constraint, let's complete this, and then I'm going to explain how this is going to work. Constraint, it's going to be customer shipping address. This is our rule that we know. We're going to just use the table name. And the primary key that we name, it's going to be the combination of 2 fields. One of them is basically user ID, and the second one is address ID. So you can create a primary key as a combination of two fields. And in this case, we are merging user address and foreign key of address, basically address ID and user ID. They'll both will combine them in order to make a unique shipping address for the specific user. Right. Once I create the diagram, you guys will get it. So, and the foreign key is going to be foreign key underscore user ID, right? And it's going to references to the table website schema, and you guys know the table name, it's called users, right? And from that table, select the user ID field, USRID, right? So basically we are saying this field exactly that you're looking at it is a foreign key. So we're telling SQL that this field that we created here in this table, it is a foreign key, right? And it's connected to our user table, to this user field, right? It's the same thing for the other one. We're referencing basically the address ID from our address table, right? So what I want to do, I would just want to create this and discuss this in further details in the diagram section, right? So I created this table. I'm going to go back to diagram section, and it says you don't have anything and do you wish to create one? I'm like, yes, I'm going to add the table. So there it is. So I want to add the address, I want to add the customer shipping, and I want to add the user. So if I close this, as you can see, basically, we created two tables. On the left side, we had the user table, right? The user table, it contains all the user information. And on the right side, we have some physical addresses. Those physical addresses, one address might belong to multiple users, and one user might have multiple addresses. How do we create relationship between these two entities, right? Between these two tables. So we create a table called a join table, right? Or mapping table, where basically this table connects the left side, which is a user table, to the right side. But this table is a combination of two primary key. One of them is a basically user ID primary key on the left side, and the second one is the primary key of the right table. So, and we told SQL, if you guys recall, if I go back, in primary key, I said I'm going to use the combination of both keys in order to make a primary key. So I'm creating a unique value by combining the left side and right side and use it as a primary key. And as active is just an extra field. So it is very, very important to understand this concept, guys. Created two fields. We called them primary key and foreign key, and then we joined them, we connected them using the command called foreign key, and use the field name, and we reference the table that we're trying to connect to. So those two fields combined are creating a simple primary key, right? Address, I'm going to select the insert. I'm going to go here. If you guys remember, I removed a bunch of things from my user table. So user ID 1, 2, 3 doesn't exist. And in order to make this tutorial match with exactly what I have in the GitHub, so I'm just going to drop this table, user table, and recreate it. So I have ID 1, 2, 3. So, but if I try to remove this table of users, let me try. It's going to tell me I can't, and the reason, I want to show you guys why. And the reason I can't do that, because there is a foreign key. It's connected, it's referring to this table by my customer shipping address. So if I want to drop that, I basically need to drop my shipping address, right? And then since I broke the foreign key relationship, now I can go ahead and delete my user table, right? And let's actually recreate the user table and insert the values. There you go. These are all the values. And all right, here's the create table command. I'm going to recreate the table. I'm going to insert the users that we had since we removed those values. And I'm going to say declare at salt. You guys remember that character 6, and the salt is going to be set at salt. It's going to be left of the values and 6 of the left. So it's going to be rand plus. There you go. So now we're going to actually create that and insert. I'm going to use the same salt key. It doesn't matter. This is just a practice, but you guys know you need to have a different salt key. So I recreated basically the user table in order to have exactly what I have in my GitHub repository. So you guys in practice, you have the same numbers. So now, since I dropped and recreated the table, I do have user ID 123. Now I'm not going to get that error. But before actually I proceed, I need to recreate that shipping table that I dropped in order to recreate the user table. Remember, I had a foreign key. So let's recreate that. Perfect. Now I'm going to say user number 1. It does have, shipping address 1, user number 2 has. So let's insert those. Perfect. So now what I'm going to do, I'm going to review all these tables together. So let's select all from e-commerce. By the way, if you guys don't want to type this, you can just simply drag and drop this guy here. And this is a new technique I'm going to show you guys. The next line, and we're going to go for not product, and the last one is user. So I'm going to say select all from, I want to walk you guys through this again, from this, and we're going to go ahead, select all. All right, so let's select all 3. Perfect. So, and then of course we do have another table that we created. It's called shipping address, right? Where is it? The shipping address we just created. Perfect. So you guys know the shipping address is basically a mapping table. It's a join table, right? And we used it to connect our user table to address table. So if I select all of these guys, let's now basically translate this data. Well, we have some addresses, physical addresses. We don't care if they're connected to a specific user, or we just want to make sure these are physical addresses stored in a separate table. We have a bunch of users, right? We don't need products. Let me remove products. And we have a bunch of users, user number 1, 2, 3, 4. And we have a mapping table, which we basically assign 2 foreign key, connected first one to this table, and connected the second field to this table. And we said the combination of these 2 tables, basically foreign key, address ID, and user ID, will be primary key for this customer shipping address table. We are telling SQL, hey, user ID number 1, John Smith, he does have 2 shipping addresses, right? 123 Main Street, New York, and 60 American Way, right, California. So he has 2 addresses. So imagine you're on a website, you want to give the user basically ability to select the address. This is the table that you're going to refer to. We're going to actually query and connect these data, and I'm going to show you guys how to query this accordingly, right? So user number 2, Kyle Adams, he only has 1 address, which is PO box address. User number 3 again does have 2 addresses, address 4 and 5. So user number 3, which is Adam Smith, he does have 2 addresses in Colorado, right? And user number 4, she doesn't have any address in our table. So basically we have the user, but there's no address for her. And also we have an address here that nobody's using, right? So I'm going to write a query here, and I want you guys to bear with me because I'm going to help you understand this really, really well, right? Now, when ordering, let's say I go to the website, to your e-commerce website, and I want to order, a few books, right? And I'm ready to, basically select my address and start ordering, complete my, basically, and I want to put my address and complete the order. So up to here is easy. So we're going to select everything from website, and we know that we have to select from customer shipping address, right? So instead of typing that, I can just simply drag and drop that. That's easier, right? So select everything from customer shipping address because we know that the relationship exists inside that table. But in order to connect these pieces of data together, we need to use a command called join, right? So we are going to join this to the user table, because we know part of the data, part of the, my first name and last name, part of my, more information, it exists inside the user table. And I'm going to give this an alias, like basically a label, right? And I'm going to just name this you, right? And the first one I'm going to say customer shipping address, CSA, right? The second join, I know it's going to be the address because part of the data, the physical address, is actually it's on the other side. And I'm going to name this basically ADDR, right? Join this on because I know in shipping address, the last table, I have the foreign key, right? And what is it called? It's called CSA. So from CSA, from customer shipping address, select the FK underscore USRID, right? So connect these two tables based on the user ID that I have on both table. And of course, from the user table connected to user ID. So let's go back to diagram. When we join, right, here's a user ID from the first table. Here's a FK user ID from the second table. So when we join, we say the first table, here's the label. So from the first table, select the FK user ID, which exists. And from the second table, join it to the user ID. Here, it's label u.userid because USRID, it exists in the user table. We're going to do the same thing on address. On address, we're going to say CSA dot. This is going to be FK underscore address ID equal to, and the address ID on the first one, what is it? It's going to be ADDR, which is the alias. I'm just referring to this table as opposed to writing the table name, right? Dot address ID. So again, this join makes sense if you look at this diagram carefully, right? So on the right side, you have user ID in the user table. There it is. It's user ID from the first table. You're joining this to the other table, which is a customer ID, and there is a field called FK user ID that connects these two tables together. So in order to put the data back, assemble the data back and get this puzzle solved, we need to connect these three pieces of data together. And this is how we are creating it back. We're putting these three tables back together. So this is the first table, which is a join table connected to users and address table. Perfect. Let's run this command, see what we get. So now I'm connecting all these three pieces together. And now you can see John Smith, as I mentioned, he does have two addresses. Let's take a look. There it is. Here are two addresses for John Smith. So now later you will see when I want to basically place an order, if I try to insert a wrong shipping address or wrong relationship, SQL Server will prevent me, right? It's not going to allow me to place an address, place an order with a wrong address because I am defining all the relationships inside the mapping table, which is the customer shipping address, right? So, and this is how we join the data to get the full result back. Let's rerun this full join. Here's all the join. But here's the fun part. You can say, hey, from the customer shipping address, the customer shipping address doesn't have any meaningful data. It's just a bunch of relationship. So what I'm interested in, I want the username, first name, and last name. Let's do that. So I want to say, hey, from this guy, from user, select the, for example, F name. And from the U guy, again, select the last name, L name, right? There you go, L name. And then from the other table, since now I'm dealing with one piece of information, I can start referring to all these. So, and then I want the from ADR, which is the address table. I do want, for example, the address. There you go. And let's confirm that the field exists. It's called physical address, actually. Perfect. So now if I run this command, you see John Smith has two addresses and Kyle Adams has one address and Adam Smith has two, exactly the way we want it to work. But at the end, what I can do now, I can say if user sends a command to my website, it says where we know the username, for example, is going to be equal to, for example, John and last name, or you can do, for example, with the ID, right? And John's ID is going to be USRID is equal to 1. We know his user ID. So he logs in with his account. We know his user ID after login. User is number ID is 1. And then when we are in the shipping page, we're going to have a query that's going to receive basically store procedure here. Shortly, we're going to build it. And when you pass the user ID, it's going to basically return all the invalid shipping addresses for the specific customer. Let's do that. So what I'm going to do, I'm going to say go create procedure. By the way, you can just use proc instead of procedure. And I'm going to say get customer shipping addresses. So from website, you will be calling this actually, and you'll be passing the user ID, and this is going to be integer. That's it. And now we're going to have a procedure ready where user ID is equal to user ID that we're passing to this function. Whatever you pass, we're going to basically query based on that. Let's execute this. This is going to have an @ sign. All right, this is going to have an @ sign and as. So we created this procedure. Now if I right click on the procedure, there it is. I have the procedure ready. I get customer's ID. We're going to execute this, and we're going to say, give me all the shipping addresses for user ID number 3, right? There you go. It says it's Adam Smith, and here's the user ID for Adam. So basically, you will be calling this store procedure from your website when the user is basically hitting your, the shipping address, selecting shipping address page. All right, now we're at the joins. Let me introduce you to this page from W3 Schools, and it's very, good visual representation in order to understand the join. And so you guys just saw we did a join, which was an inner join, and returns records that have matching values in both tables, right? You saw that we were able to collect the shipping address for a specific user. We do have also left join and right join and full join. As you can see on the left join, when we do left join, we're basically selecting every single value from the first table, right? And then on the right side, we're only selecting the values that exist in the table number 2, right? In the table number 1. So those are the values that we're selecting. There you go. So return all records from the left table and the match records from the right table, right? Same thing on the right join. So we're returning all the records from the right table and the match tables from the left one, right? And then returns all the records when there's a match in either. So this will, let's say for example, you have user number 10, but there's no mapping for the shipping address. So the right side will be just null, but it will select as soon as you have a value. It's either on the table 1 or table 2, right? So this is called full outer join. So these were just the values that join, different type of joins that I wanted to show you guys. So now I want to go ahead and create an ordering table, and I'm going to introduce some new cool concepts here, guys. All right. So let's create a new table. Create table, and it's going to be a website, right? Dot orders. All right, and it's going to be, of course, the drill, order ID. It's going to be int identity. If I spell it correctly, I'm going to start with 1000 and 1. This is going to be not null. If someone orders, there needs to be an ID for that. Now I'm going to create 2 foreign keys, right? One is going to be user ID. You know why? Because I want to connect this order to a specific user. We are in relational database, guys, and it's going to be not null. And foreign key, and it's going to be shipping ID. We're going to refer to that shipping ID, right? And this is going to be again integer and not null. Can be null. So we're going to have an order date, and order date, we're going to introduce a new data type, which is date, and it's going to be not null. And order total, it's going to be again decimal, 19 and 4 precision for the values after precision, after dot, and then this is going to be not null. We're going to create a constraint, and the constraint is going to call pk underscore orders, table followed by table name and followed by primary key, right? This is how we basically label this. Primary key space, it's going to be order ID and user USR ID, right? So again, my primary key is basically a combination of 2 fields, right? So I want to make a primary key that's using my order ID, right, and my user ID, right? These 2 values, they're going to create my primary key, and I'm going to create, of course, 2 foreign key. As you guys know here, we're going to have foreign key, and the foreign key that we're trying to make, this is one of them, right? and it's going to references, basically it's referencing my basically user table, and I'm going to just drag and drop user table, and inside the table I know I have USR ID, and I do have a second basically foreign key, which is going to be of user ID, right, and foreign key of shipping ID, both. So basically address ID and user ID. This will be connected to my shipping address. You guys remember I had the mapping in here. Foreign key of user ID, because inside this table I do have two fields that I want to refer to. So let me remove these brackets. So let me now explain what's happening here. Let's see if this command works. Let's rename it, execute it. Yes, it worked. Now we have a ordering table, but I'm going to explain exactly how this is going to work. And I can do that better when I have a database diagram. So let's go ahead and create a new diagram. I'm going to add all these tables right here. All right. And I don't see my table. All right, we did create the table. Again, diagram. Refresh. There you go. All right. So if you guys take a look now, we are already familiar with customer shipping address, and we are already familiar with address ID. Sorry, we're already familiar with address ID as well. Let's take a look at the order table. In the order table, we are connecting the order to the user, right? Because we want to just return the users that are valid for a specific user, right? It makes sense. And at the same time, we are connecting our orders to shipping address because the order needs to go to the physical address. But at the same time, we know the customer shipping address table already knows how to deal with addresses. It already knows that, hey, all the shipping, for example, orders need to go to John Smith. He only has 2 available addresses based on the relationship that we built in the prior step, right? But our order now has 2 foreign key connected to foreign key. One connected to user ID because we are interested in connecting our orders to a specific user. And also we need to connect this back to the shipping address. But since shipping address, you guys know, has 2 IDs in it, basically 2 primary keys, we need to connect those 2 fields to exactly 2 fields that we have in this table, right? Which is a user and the shipping ID. This could have been like address ID, but it doesn't matter. We just created it. That's just the name of the field. So I do have 4 scenarios. Scenario number 1, John Smith, user ID number 1. Now we're going to add some insert, right? It's simple. So insert foreign key for user ID. So John Smith is ordering 1 camera, right? And shipping address is 1. So the order total is 200, right? This is the first user goes to our website, it's ordering a product, and we're going to see how it goes, right? So the order total is 200. Order date is get paid. You guys see it. Shipping ID is going to be 1 right? So user number 1 has a shipping ID of 1, right? And user number 1, again, John Smith is ordering 2, this time 2 iPads. You see now that it's 300 times 2 will be 600. We're going to deal with all these calculations later, right? And it's ordering and it's going to address number 2. Again, Kyle Adams and Adam Smith. So we have a bunch of scenarios here that's at the translation you can see underneath. And I'm going to insert these values inside the table, right? So the order total, it says doesn't exist. That's correct. Order total. So I actually misspelled total. And what I'm going to do, I'm going to actually, you guys know, I'm going to drop the table. If you're not familiar with table, with this concept, drop table basically drops the table, and we can now recreate it. There you go. So now we're going to run our inserts. Perfect. So if I actually go ahead and select these values now, select all from this. All right. Now you're going to see we have order ID number 1000 because we said all the identities is going to start from 1000, and we have a relationship and the order date and the total number. What I want to show you guys here, based on the diagram that I have, I know that user number 5 which was Susan, right? Or yes, it was Susan. Let's confirm that. So user number 4, which was Susan, right, doesn't have any address in our table, right? Remember, in our mapping table, if I want to show it to you guys again, all right, the first one. So the second one was address, and the third one was customer shipping address. So if I run all these 3 commands, you guys are going to see in the mapping section, user number 4 doesn't have anything right in here. Or let's pick a user number 2, for example. User number 2 only has relation to address number 3, so only can use this shipping address. But what I want to do, I want to select user number 2 and select the wrong address to see if I'm going to get an error or not. So let's copy one of these inserts, right? So user number 2 only has access to address 3. So you can only ship packages for user number 2 to shipping address number 3, right? This is the relationship it defined, right? No argue here. So user number 2 only can receive packages through this address. So if I put the wrong address, number 5, I'm going to ship this to number 5, and I'm going to just send him $1,000 Dell laptop. Let's see if I can insert that. Perfect. I'm getting an error. The insert conflict the foreign key because I'm conflicting the relationship in this customer shipping address. There's no transaction, there's no translation between user number 2 and address number 5. I cannot place an order and ship it to a wrong address. SQL Server understands this relationship and doesn't allow me to do it. All right, now I'm going to create an actual join. It's very clear what's going to happen. And in this join, you guys are going to see how we retrieve in a specific order for a specific user. Let's try that. So for user number 1, he's got 2 address, order ID 1000, is the order history. Basically, if the user comes to the website, hey, show me all my most recent orders. So you ordered $200 John Smith, and here's the physical address you shipped to. But we're selecting and keeping all these records in different tables, but based on the power of join, we are reconnecting the data based on the fields, and we're connecting it back together to make a meaningful, translation for data. So in this example, we're selecting star. For now, this is going to return everything. See, now it's like returning every single piece of information. So select all from ordering table, right? And on ordering table, you guys remember that we had columns, all right, which was user ID foreign key and shipping ID foreign key, right? So we're going to connect that to our shipping table. There you go. So with customer shipping address, we're going to connect 2 fields from our ordering table. See, from ordering table, we're connecting the both tables back to our basically customer shipping address, right? Which was the mapping table. There you go. Here's the mapping table. And now at the next line, we're connecting our address, right, to our customer shipping address to get the physical address, and we're joining it based on address key ID. And we're connecting at the end to the user to get the user ID, and so we can filter based on user ID. And at the end, we're saying, hey, only give us information for user ID 1. If I remove that guy, this is going to return every single relationship, all the orders for my website. So this is how we connected data, right? And we're joining back. And the reason we have 2 pieces here, because our customer shipping address, again, the mapping table had 2 foreign key to 2 different table. So we are connecting it back using those relationships. And the rest is easy. So we have 2 more joins that's connecting to address and user table. All right, guys, now we're going to actually create our order details. In order details, same drill. You have the order ID identity integer that's going to just be used as a primary key. I created only one foreign key that's connected to my products, because you can definitely go ahead and connect this back to your order ID. We had 2 primary keys in order table based on the order ID and user ID. You can use the same concept, right? But for now, I'm just gonna, continue this as a simple route. I want to show you guys, if I select my orders, here's the orders. There you go. And you guys remember we ordered all these things, and then we knew that user John Smith, for example, ordered one, for example, camera, right? So we're going to actually insert all these values to our tables. All right, so let's create the table, because every single order might have multiple items. All right, let's execute this. There you go. Now we do have the order ID, and we have an order table and order detail. Let's refresh our tables. So there's going to be one order, and the second one is going to be order detail. Perfect. So it's going to be select star from copy, paste. There you go. We're going to select those two. So order ID number 1000, and as you can see, it's number 1000, and it's using product number 100, right? And product number 100, if I go ahead and insert the product, you guys should see the product as well here. Perfect. Let's see, product 1000, there you go. Product 100 is our Canon that's been purchased by this user number 1. All right, so we added some order. Now if you want to join this to order details, for example, we can go ahead and write a simple query to select all these guys together. So for now, I'm going to say select all from my order table, right? Actually, I can just go ahead and simply use this as my query base. So I'm going to join this with multiple things, right? Join. All right. And I am going to join this to order detail, for example. I'm going to connect this to users because I'm interested to see who ordered this. I also want to join this to my products. All right, and this is going to be USR, for example, on my order dot USR ID. It's equal to USR dot USR ID. Perfect. And the other one is going to be order, basically details, order, let's say ORD detail, just making up this labels, and where order dot order ID, it's going to be equal to ORDD dot foreign key. If you guys remember, it was a foreign key of order ID. All right, this looks good. I'm going to name this PRD. And if you guys having trouble on looking all these, I definitely recommend you create the diagram. Take a look at the diagram so you can find out why I'm exactly using this field. But if you guys remember, in order details we had this field, right? There it is, because that's how I do it. I select all these tables that I'm trying to join, and then I start writing the query so I can see the fields from different tables. Just a trick, so you guys can use. So PRD, the product ID, is going to be equal to ORDD, which is this guy, and it's going to be dot FK foreign key underscore order ID. All right, let's see if this join is going to work. User ID invalid column. All right, perfect. So as you can see, returns nothing, and the reason is in order details this should be foreign key of product ID because I'm connecting to product ID. Let's rerun this guy. Perfect. So I do have all the orders with the order details. So what I can do here now, I can say give me user.USR ID, right? And again, from the user table, right, give me, for example, user name and last name, fname, and user.lname, for example. From product, just give me, from product table, just give me, for example, the product name, right? And from ordering table, give me order date, And for example, we have order total, right? And we can say from order detail, give me the quantity, right? QTY. And from product, give me the price of the product, comma, from order detail dot QTY times this product dot price, because I want to time, basically multiply the quantity and price to get the amount, and show me this as an amount. So let's run this guy. We are having an error here. Let's see why. Order date, order detail, perfect. Let me remove that. There you go. So John Smith ordered Canon on this date. Order total was 200, and it was one item, price 200. So the amount, this is coming from invoice detail. However, John Smith again ordered another 600 total, but there are two items on the order, which was 300. So this way you can basically connect the order detail, and a user can have multiple records. And basically I'm calculating the amount was by multiplying the quantity and price. All right, guys, I want to talk about another concept, which is a local table, temporary table, and global temporary table. So imagine I create a table like this, and I want to say this is a local temp table, and this is how you create it, by adding a basically hash sign. And I'm going to say I'm going to have a first name, right? And then this is going to be varchar 40, and let's say for example last name varchar 40 again. So I can actually, let's say I want to store some temporary result into this temporary table, and I want to dump those data in that and do some calculation, and then again dispose it afterwards. So the way it's going to work is going to be, for example, insert into this local temp table, right? Values, let's say John Smith, right? And there you go, Smith. Right? So the way it's going to work, if I run this program, this query, you're going to see I have one record in the table. There you go. I have one value here. But if I open a new connection, right, and start querying this same table, there will be no such a table, because local temporary tables are just basically they're available, they're visible for the existing connection. So it's very useful when you're doing some calculation for user, you're calculating some discount for the product. You can put the results temporary in that, and then of course do some calculation. For example, I'm going to say, hey, update this local table, right? And for example, set, let's say you can change something. Let's set first name equal to Adam, right? And then you can just update the temporary table, and then do some calculation, update the value, and then you can insert the value back to the main table, for example. Another one thing that I want to show you, for example, if we go to orders, right, and we do select all from orders. So I can put the result, I can put all the orders in a temporary table like that, and I want to say temp, right, into this temporary table. And now I can do some manipulation on data, select all from, let's say hashtag temp, and there it is. So now I can say, hey, for example, I want to update the order, basically order date for order 1000. And then you can do some calculation and then put it back to the main table. You get the idea. So temp tables are very useful. I would like to add that you can also create a global local table, and global local tables are available for all the connections. They're basically shared. Let's say, imagine you want to share some facts and some maybe shared information between your connections while your database is running. You can definitely do that, right? There it is, already in database. The first one I went through. Now the insert, we inserted into global table, and now if I run this table, I have the same result. However, if I open a new query and I run it, I will be able to access the same table. There's one more concept I want to discuss here, and it is very useful, but you have to be aware that they're very expensive. They're called cursors. If you want to create something like let's say for loop in SQL, this is how you do it. Let's say we want to build a procedure that we want to go through all the orders and some sort of double check the payment, make sure everything is fine. So like an auditing procedure for every single row, we're going to call a very heavy, long running, for example, job, right? How do we do that? So we're going to create a cursor and we're going to say declare order audit cursor, right? And we're going to create that cursor. Once we declare that, we're going to say for, what is it for? Is for select order ID from website dot orders, right? And this is going to be for our orders. We're going to say open the cursor. Let me copy the cursor name. So we're going to say open the cursor and fetch next from fetch a record from this cursor that I just created, right? And put it into the variable that I have, order ID, right? Great. And do this while at fetch status equals 0. It means there is something to process. I want to do this auditing process. And at the end, of course, I want to close the cursor because again, they're expensive. You want to make sure you deallocate the memory that you gave this cursor. All right. And we're going to say print auditing order number, whatever the number is, which is going to be cast off at order ID and as varchar, right? I'm going to copy this guy and then we're going to fetch the next one, fetch next from order audit cursor into at order ID, right? And then once we fetch that, we're going to say print. So actually we can say called another store procedure for a long running audit for auditing, for example, right? Let's say we call this a procedure, goes check some APIs, go checks the banks, and we do stuff, and then we go next record and next. So once we are done with that, we're going to say, hey, we are done. We're going to say print audit is done. Audit finished. Auditing order number, whatever the order number is, and then we're going to fetch the record, and then I'm going to put some empty space here, and we're going to fetch the next record, and we're going to go through this loop forever. I mean, as long as we have an order, we're going to just basically audit every single order. Let's execute this guy, see what it says. It says order audit cursor doesn't exist. Audit cursor, that's going to be order audit cursor. I had a typo here, the name of the cursor. Perfect. And does not exist. Yes. All right, for the last time, let's run it. We're going to close this guy. Let's rerun it again. Perfect. So you see what's happening. We are pulling every single order that we had, and then maybe we can add the print here, calling processing the order. So what's happening basically, it goes and checks the bank and it does a bunch of other things and says, hey, finish processing this audit, finish process. So you see we have a loop that we're going through every single row and we're doing some heavy calculation here. All right, guys, in order to migrate your database to Amazon Web Services, the first thing you're going to need is basically a connection from your on-prem data center on the right side to Amazon Web Services, right? This connection can be built using something called AWS VPN service, which uses public internet and establish a VPN IPsec tunnel on top of internet connection. But you have to pay attention that you are going through public internet from your data center to Amazon Web Services. Right? The speed might vary, so you have to be aware that VPN tunnels, they need to be redundant. Usually what they do in order to make them resilient, they build basically 2 VPN tunnels, and you need to build route from your local data center to Amazon Web Services. If you don't have access to this technology, that's the first thing you need to do before actually migrating your database. There's actually a better way if you are dealing with a big corporate and if you are actually sending and receiving a lot of data to Amazon Web Services. You can use something called Direct Connect. It's a 10 gigabyte or 1 gigabyte, dedicated connection. It's not encrypted, in nature. So you have to build VPN tunnel on top of Direct Connect. But it will give you, consistent, reliable connection directly to co-location that it is connected to Amazon Web Services infrastructure. It's a very reliable way of connecting your data center to Amazon Web Services if you have a lot of usage. It's an expensive service, but if you have, again, a lot of data in and out of AWS, it's actually cheaper to use Direct Connect as opposed to VPN for public internet speed and paying for internet. So Direct Connect has 2 types of connection, which is private WIF and public WIF. Public WIF is basically used to connect to AWS public services. When I say public, that doesn't mean internet. It means AWS public services like Amazon S3. And you have private WIF in order to access, your VPC and private resources. So in order to actually use database migration service, you have 2 options, Direct Connect or AWS managed VPN. However, for the purpose of our practice, we're going to actually build a EC2 instance in our Amazon Web Service, and we're going to pretend that's actually in our data center since we're not interested in making this Direct Connect or VPN tunnel, and we're going to assume this server that we are running on Amazon, it's our on-prem server, and we're going to start learning about database migration service. So there are 2 things I want to talk about database migration service. As you can see in this picture, on the left side, I have an Oracle database that I have on-prem, and I wanted to migrate this to Amazon RDS, which is a managed relational database by Amazon. It's an amazing service, but they have a compatibility for example, Oracle. So imagine that you have this on-prem data center. There's a VPN tunnel or Direct Connect to AWS. So you use AWS Migration Service, which basically launches a replication instance, EC2, and starts copying data as a bridge to migrate your database to Amazon Web Services. That's how you migrate it. But the point here is I'm migrating my Oracle database to Oracle database, or I'm migrating my MySQL database to Amazon Aurora database compatibility of MySQL. Aurora has MySQL engine and also Postgres. But think about this, that both source and target databases are the same. So this is called homogeneous, right? Database migration. So when you are using a same version on the target side, the AWS migration service can just simply launch the replication instance and start copying data automatically, right? So there's a second scenario that your source and target database are not exactly the same. So that needs to happen into 2 steps, right? The first step, you run a tool called schema conversion tool, which basically explores and finds all the, data schema and things that you have in the source, and converts that into the target database. Let's say you want to move away from Oracle based on the cost, based on things, and you want to start using Amazon Aurora, which is a much faster, cheaper in terms of licensing, database option. So in the second step, once the compatibility is resolved, you're ready to, convert your database, then you go ahead and launch the database migration service, and you create a migration job, and you start the process. We're going to actually build in an EC2 instance. we're going to pretend that's on our on-prem data center. We're going to put our e-commerce database that we built, and I'm going to show you how to create a script out of your database, and then we're going to move that to EC2, and then at the end we're going to use AWS migration service to migrate the database from EC2 to Amazon RDS. Alright guys, the last piece I want to show you guys is to move your test database to, for example, your test, which is going to be an EC2 server. There's going to be a test server, but since we don't have VPN or direct connect, we're going to pretend that EC2 instance we have on the cloud is actually our on-prem database. So you can right click and go to tasks. You can definitely back up and restore. Since this small database, you can just back up this file and move this file to your EC2 and restore it to your SQL server. That will be your first option. The second option will be you go right here and then you say generate script, and you can create a script for your database. You can say all the object or specific one you can pick from the list, but in this case I'm going to go for everything. And there's going to be a file called script.sql, which SQL Server is going to create. And once the file is ready, we're just going to go ahead and copy this file right here to our EC2. Here's the file. Take a look. It's going to create everything that we discussed in this course, and it's going to just create the database. In real life scenarios, you might have VPN tunnel, direct connection to cloud, so you can basically start transferring databases from on-prem to AWS. Since we don't have that direct connect set up, we're just gonna build an EC2 and use it as on-prem database server. So let's start by creating a launch instance, and we're gonna go here. I'm gonna search for Windows, and this is going to be giving me some options. I'm gonna select Microsoft Windows Server 2019 with SQL 2017. I'm going to select this guy. Since it comes with database, this part might cost if you don't want to follow, but be aware that if you use this, there's going to be a little charge on your account. But I'm going to use a for example instance which is M5X large, and we're going to continue. And I am going to use the default VPC, which has internet gateway, and it has public subnet. I'm going to use US West 1, and I'm in Northern California region. And I'm going to actually go ahead and enable having public IP, since I want to connect to this database. I'm not concerned at this time about security, but you guys know how to basically secure an instance by applying the appropriate NAC hole around the subnet or security group on ENI. All right, so 50 gig is fine. We're going to go ahead and do next. For security group, we're going to need RDP, which is going to be 3389, and it says from everywhere. When you have 000/0 means from everywhere you can basically access this instance. And then my MS SQL Server port, which is 1433, is also open, so we can connect to it. All right, I'm going to go ahead. It's warning me that it's open. I say I understand that, and I'm going to just create a new key. For example, create new key. I'm going to say e-commerce, right? I'm going to download the key. Perfect. And I'm going to say launch instance. Well, while this is launching, if I click on view instance, I'm going to have an instance, and it's going to shortly, and I'm going to name this actually on-prem. It comes with SQL Server. We're going to use our backup that we created from the earlier section, which was the e-commerce back. You just right click on database and create a backup file. This is the back file. We're going to transfer this file to basically our instance, EC2 instance, and we're going to restore it. This is going to be my public DNS, but usually it takes a little bit of time for Windows Server to open up the RDP session. You see it says initializing, so still too early to connect to it. But in the meantime, I can go ahead and start building my RDS. So let's say you are hired to basically help this company. They have an on-prem machine. This is on-prem machine again, and you want to help them migrate their applications to their databases to RDS, for example. So we are going to use Microsoft SQL Server. So the target database is going to be a Microsoft SQL Server, and as you guys know, our source database, which is the on-prem instance here, is also Microsoft SQL Server. So we're just going to go ahead and create a database. Perfect. We're going to go with a standard. We're going to go with Microsoft SQL Server. And if you go down, you see all the different edition that you have here. We're going to go with Express Edition, affordable database management system, up to 10 gigabyte. The version 2017 is fine. A license included. Getting this license through Amazon Web Services. We're going to just go for free tier. We are going to say the type of name for your DB instance. This is going to be for example, Commerce DB, right? And sorry, I think I misspelled this. E-commerce DB. This looks better. And I'm going to just use the master username as, again, e-commerce, and the password is going to be same as this. It's going to be e-commerce and e-commerce. I'm going to go ahead and select T2 Micro as our DB instance size. I know we can go for probably bigger versions, but since we want to stay in free tier, we can just go ahead and do that. If I don't want to do that, I can just select the dev and test, and hopefully I'll get more options here. For example, let's say I want to go with T2 medium, and you guys can just go for a free tier, so there will be no charge. And I have 20 gigabyte for storage, enable storage auto scaling, and I'm just going to keep everything as default. My default VPC will be used for this, and no authentication. Enable Microsoft Server authentication. You can basically integrate add basically IAM role necessary for Windows authentication. For this case, we're just going to keep it disabled. So this is for every 1 month you're going to have $81. Of course, because I'm using T2 medium. If I go to T2 small, you're going to see I'm going to drop it to probably around half. So let's get create the database. So we have an RDS instance now. And this RDS instance, it's basically using engine Microsoft SQL Server, but RDS is basically a managed server. It's a great service by Amazon Web Services. Since it's a managed basically infrastructure, you don't have to maintain anything as far as underlying operating system, patching that. So Amazon will take care of all the things for you. All right, guys, my instance is ready. Now I can connect to it. So I'm going to select my on-prem. I'm going to say connect, and I'm going to download the RDP file, which is a public, basically DNS. So if I click on this, I'm going to go ahead and connect. It's going to ask for the password. And since you guys don't have the password for first time, remember we created a key called e-commerce during the setup, and you go ahead and click on get password, choose the file, and automatically will basically copy the private key. Then click on decrypt password and use this administrator password, username password for this connection. I already went ahead and added that and click remember me. So when I click on the RDP file, it will automatically take me to the instance. So now we have a connection to our instance, and you guys know we selected an instance type that actually comes with Management Studio, right? And I'm going to go ahead and find a SQL Server Management Studio and copy the backup file into this folder. Perfect. So I do have the e-commerce file here. The SQL Server is loading, so we're going to go ahead and restore our local database into our actual database server, and we're going to pretend we know this is a on-prem database server. I'm going to go back to my RDS, and we're going to basically refresh my database. The database creation is done. However, perfect. It says info available. So while that's SQL Server is loading on my server, I want to show you guys something quick here. If you take a look at the connectivity and security in the RDS, this is basically the endpoint that I can connect to, and I'm hopefully publicly I can access the database. So I'm going to copy the endpoint. I'm going to go to my local SQL Server. I'm going to say, hey, I want to connect to this database if possible, so if it's a public. And I'm going to say e-commerce, e-commerce. username and password that I chose during the setup, and hit connect. So long story short, this is not going to connect to my RDS, and the reason for that is if I go back to my setup in RDS, you guys are going to see in the security section, this database is not actually publicly accessible. So while the setup and then VPC does have the internet connectivity, but the database itself, it's not publicly accessible. And this is best practice when you're creating in RDS, so you can just only set up this security group to receive traffic, for example, from your backend server, not from public internet, right? This is a best practice. But for the purpose of this project tutorial, I'm just going to go ahead and modify this guy, and I'm going to make this publicly available. So let's see if we can do that. Yes, there's a section here that I can select, say, hey, please let people connect over port 1433 to this database server. So I'm going to hit OK, and it says you want to change it, apply it immediately or during the maintenance time. You can always set up maintenance time for your RDS database. Since this is just a test, I'm going to go ahead and immediately apply this change. And perfect, my database is modifying in the modifying stage now, as you can see, because I changed the major security feature in my RDS. While this is rebooting and getting ready, I'm going to go back to my RDS and hopefully the SQL Server is ready. Perfect. So this is my basically EC2 instance, the instance that comes with a SQL Server, and I'm going to connect to it. Perfect. So what we're going to do, we are going to actually restore our database, right? This is, let's say you're working for the company, you built the database on your local machine. Now you want to move it to, for example, on-prem server, right? We haven't even started the migration to cloud yet. So I'm going to go to databases. I'm going to right click on it, say restore database. You guys know I copied it into C drive. If you remember, it's in C drive, and there's a folder called SQL. This is the backup that I exported from my local machine to on-prem database server. So I'm going to say select the device, add. There's a path to my database, which is going to be C, SQL. Here's my e-commerce. I'm going to say OK. And I'm going to say restore this guy. And it's going to say database restored. Perfect. This is our database that we created on our local machine. And we were able to backup restore this database to our on-prem EC2. The reason, again, we're doing on-prem EC2 on AWS because we're going to pretend this is our local database on-prem in our local network. So the database is there. Everything looks fine. I am going to disconnect, however, and connect using my e-commerce. We did restore our database. However, we did not restore our security and login. So for the purpose of this tutorial, I'm just going to use SA. You guys can go ahead and create the same e-commerce login on the on-prem EC2. Make sure your SA is enabled, and we're going to just go ahead and reset the password of SA. I'm going to say e-commerce. I'm going to say e-commerce. Reset the password. We're going to disable, and we're going to reconnect this time using SA and e-commerce. I'm going to say remember my password. There you go. Now I'm able to connect to my source database using SA and e-commerce. Perfect. So this is fine so far. We're going to minimize this. We're actually ready to work with database migration service. We're going to have a replication instance. It's an EC2 instance that's going to copy information from source to target, right? It's going to sit between source on-prem in AWS. And its job is basically copying data from source to database. We'll be creating two endpoints. One of them is going to be source. One of them is going to be target. And then at the end, we're going to start a job basically that's going to create and copy information from source to a target. Let's actually build our replication. And here's replication. I'm going to run on T2. This is basically an EC2 instance. 20 gigabytes should be enough. I'm going to go to my default VPC, no multi-AZ, since we're not building a production level, replication model. default VPC. No, I'm going to go with, for example, 1. Security group default should be okay for now. And AWS KMS will handle basically the key, master key for us. You can define maintenance, and also you can tag your replication instance. I'm going to click on create. This is going to actually create an EC2 instance for me behind the scenes that's going to copy basically data from source to target. I'm going to go create 2 endpoints here. As you guys can imagine, one of them is going to be my target. Let's do the easy one first. Is going to be RDS, and we have an e-commerce DB. There it is. It's a SQL server. It has everything. It says username e-commerce. All I need to do is just I need to copy the password here. Type the password here. Perfect. And no endpoint specific setting. KMS all the default setting. And I'm just going to go ahead and run test to make sure the database must be provided. That right, our database name, actually we don't have anything yet. We're going to go ahead and, for example, we're going to create a database called e-commerce, same as the source one. Perfect. And we created this on our RDS. Look, I'm connected to my RDS instance, and here I'm going to say e-commerce is my database name and run the test. It says it's already in use. Replication. We're going to actually create the endpoint for now, and we're going to create a second endpoint, which is going to be our source. Our source endpoint is basically the address of our EC2 instance. There it is. It's public DNS, and here's our endpoint. The engine is going to be SQL Server. Endpoint identifier, I'm going to say just MS SQL endpoint. Perfect. Here's the server name. Awesome. Port 1433, and no SSL. We're going to use SA, and the password was e-commerce. All right, and the database name is e-commerce. We're going to go ahead and run a test on this one as well. There you go. It says testing. All right, guys, as you can see, this one says successful, so I'm going to create the endpoint. So the first one was successful. We had problem with our RDS. I'm going to go back to my RDS. I'm going to go to connection. I'm going to say test connection. All right, guys, as you can see now, we can connect also to our RDS. Remember, e-commerce-db, it was the identifier, and I connected using to that identifier and created the e-commerce, but this table is actually empty. This is just an empty database on my RDS site, and I do have a full database on my EC2. So I do have 2 endpoints. They're both successful. Now I can go ahead and actually start the migration process. Let's create the migration. I'm going to say task. All right, migration task, replication instance, the one that I created. And it's going to say who's the source, Microsoft SQL endpoint, and who's the target, e-commerce DB. That's the identifier on my RDS because the target database is on RDS. And migrate existing data and replicate ongoing changes. This means if I go ahead and change things on my source database, basically this replication instance will replicate data. So for example, you're working for a company and they'll tell you, okay, now it's June 8th. At the end of the June, we're going to do cutover. We're going to actually retire our on-prem database, and we're going to move to AWS RDS. So on the date of the basically cut over, what's going to happen, the programming department is going to update the connection string to point to RDS, right? But after the initial migration, you want to make sure for the rest of the month you are actually replicating data so you don't end up having wrong and old outdated information. This is very important to understand. So I'm going to just use the default values here, like change data capture. Don't use custom stop mode. You can actually, say, hey, stop doing around this time, so you can just identify that. And if there is a large objects in your database, chunk them into 34 or maybe 64 KBs and send them, because they're going to be creating a performance issue for database. So of course, CloudWatch enable CloudWatch always have the logs. Is great to have on your infrastructure. And editing mode, this is going to be GUI, and at least you're going to need one schema to to have to start the migration job. And I'm going to say schema name, I'm just going to leave it empty. It's a wildcard basically, and I'm going to say create task. All right guys, I'm getting this error that says the distributor has not been installed correctly. All right guys, now we're going to actually create a distributor. The password does not meet the operating system complexity. All right, so we're going to say e-commerce, and there you go. We're going to make it a little bit, hopefully, stronger. There you go. The agent SQL Server is just not running. So what we're going to do, we're going to go to SQL Server, and actually we could start it from here. I'm going to right click on it and start it. The reason the distributor is not working, because this server is not set up as a distributor or local one. So we're going to just go ahead and start this as distributor. There you go. We're going to create this guy. It's already identified, and we're going to add this perfect to our distributors. Now if I run the this command, you guys are see we have one installed one, and this is my distributor. To my migration task and go back there. And if I restart the job, hopefully I should be seeing the progress of data migration very, very soon. All right guys, now you can see it says load completed, replication ongoing, progress 100%. If I go to table statistic, now you guys see that we do have basically some full rows that being converted and migrated to our basically target database. So if I go back here, I am going to actually disconnect from my local server. I'm going to connect to my RDS, which is a target database, and I'm going to open my e-commerce. Here's all my tables sitting here. So if I search, there it is. I do have everything from my source in my target database.
All right guys, I hope you enjoyed it. Don't forget to like this video, subscribe to my channel. Let me know if you have any questions in the comment section, and I hope to see you guys soon. Bye.